Hello, students.
Hi,
It's
students.
me, Mr. Hernandez,
And me, Miss Lisette.
and we're here to go over the sticky tape activity with you guys. So let's start with the basic setup for the sticky lab. You have a base piece of tape, you have the bottom piece of tape right here, and you have the top piece of tape. So you were supposed to label those T for the top, B for the bottom, and the base will just stay on the table. All right, we're just gonna scroll up a bit. Let's get rid of this.
All right, so you want to make 2 sets of tape if you're doing this at home, or you could just follow along with the video, and you're going to label them with T and B, as we said before. You're also going to do this with 2 pieces of paper, so you should have 2 strips of paper, and then you'll label them with P, so you know it's paper. You're also going to make 2 strips of aluminum foil and label them F, so you'll have 1 hanging piece of paper and 1 hanging piece of foil. All right.
All right, so we're gonna keep going through it. So if you're just watching the video, you're gonna see the instructor with a few pieces of material. And on your lab sheet, here we go, we have the foil here. We have the paper right here, the top tape, and the bottom tape. Not to scale, very important there. All right, so what he does then is he connects, or he gets the second set of top tape, bottom tape, and he brings those close to each one of these materials. And we're supposed to write down what we observe. So we're gonna go right to that part right now. So sketch with labeled force vectors for 2 top tapes. So what we should have here is just, we're going to try and sketch this out here. We'll say T1 and T2. So when it's saying force vectors, we want to pay attention to whether those pieces of tape are attracted to each other or if they are repelling one another. So if these are both T1 and T2 in the video, we should see that T1 pushes T2 that way, and T2 pushes T1 that way. Just like that. That's something like this should be on your paper. So we'll even label that T2 on T1 and T1 on T2.
All right, so for this one, you're doing the same 2 pieces of tape, but it's half as far as the left sketch. So if you're having 2 tapes that are repelling each other, or they're closer to each other, you should draw them closer together. So eyeball it as half as far apart, right? And then you should see a bigger repelling force, or that they are moving far apart from each other, a bigger distance. So again, this would be T2 on T1, and this would be T1 on T2.
All right, so describe the paper on paper interaction. So right now I have a copy of this lab. You can kind of hear it. I'm bringing these papers together and nothing's really happening. So for that box, we're gonna write no attraction. And then for number 9, describe the foil on foil interaction. I don't have any foil on my person right now, but we can assume that I've cooked before and there's no attraction there either. And they don't repel each other either. That's an important point to put on there. Bring 2 pieces of paper close together, they're not pushing each other away. Bring 2 pieces of foil close together, and they're not really doing anything. So now, Miss Lisette's going to describe what happens when we bring a top tape and a foil close together.
Yeah. So if you're watching the video of the guy with the setup, what you'll notice is that he brings the top tape, and you're going to draw a picture. So you bring the top tape close to the foil, and what you'll notice is that the foil becomes attracted to that top tape. So label this F. So you'll see it slightly move, right? And then the direction of that foil would be towards the tape. Okay? So tape on F.
Cool. And now we have the top tape and paper interaction. So if we have our top tape right over here, and then we're going to bring our paper slice right here, we want to pay attention to what happens. So we should observe that the top tape is pulling the paper. So top on paper. So for this one, we'll write attract, and that means that, oops, let's not worry about that right now. That means that this one is also going to attract. Interesting, because when we had two pieces of paper close together, nothing happened. Two pieces of foil close together, nothing happened. But when we bring one of these top tapes close by, it pulls the foil and it pulls the paper. So now we're going to check out top tape and other interactions.
So you can imagine after doing all of these things, so top tape and top tape are similar to each other, and they actually repel, like he shows in the video. And if you're doing this at home, this is what you should have observed. So what you'll do is you have your top tape number 1, and then your top tape 2, and it'll slightly, your top tape number 1 will slightly repel this one. So you should see it moving away. T1 on T2.
And then for top tape on bottom tape. So now we're bringing these two different ones together. And what we should see is if we have our top tape here and our bottom tape here, we're paying attention to what happens to that bottom tape. We should see the bottom tape get attracted to our top tape. So we'll say T on B, and we'll say attract. Cool. All right, so interesting interactions. We had top tape, they repelled. Top tape on a bottom tape, they attracted. So now we're going to bring the bottom tape close to some of these objects.
All right, so we have a bottom tape and foil interaction. So if we think about what we've observed before, foil interaction, no, you don't have any interactions or like no attraction at all. Your bottom tape with a top tape has a different type of interaction, your bottom tape and bottom tape interaction. So it's you can assume what you would observe, but you can also watch the video or do this at home. So what you'll notice is if you have your bottom tape here and your foil should be slightly attracted to this bottom tape. See? So B on F attracts.
All right, now we're going to have our bottom tape and paper interaction. So we have our B tape here and our paper. So diagram with forces and describe what happens. When we bring that bottom tape close to the paper, it also attracts. So we'll say B on P. We should have an attract there. All right, so bottom tape on top tape.
All right, so bottom tape on top tape. So this is your top tape that is taped to the table, and your bottom tape, you're bringing it towards it. So what you should observe, right, we have two tapes that are not similar to each other. You should see an attraction. So that top tape moving towards that bottom tape. So that's going to be B on T and then attracts.
All right, and then bottom tape on bottom tape. Let's see what happens here. So in a video, our instructor brought those close together. And what happened? We noticed that they repelled each other. So there's something about these bottom on bottom, top on top. Something's changing there between those. All right, so now we have our PVC pipe and paper interaction, and then he has a lucite rod and different interactions from there. So let's start with that PVC pipe first. So PVC and paper, after he charged up that PVC pipe, oops. What did we see happen, Miss Lisette?
So PVC pipe and paper interaction, you should see the paper being attracted to that PVC rod. Fun fact, PVC stands for polyvinyl chloride, and it's a type of plastic. Yeah.
Oh, that's cool.
PVC rod and foil interaction, you should also see an attraction as well. PVC and top tape interaction, you'll also see an attraction. So we're starting to see a regular pattern here, but when you have a PVC rod and bottom tape interaction, it actually repels, according to the video. And then he changes to a lucite rod, which is a glass type of rod, and does the same methods. So lucite rod and paper interaction, it's an attract. Lucite rod and foil interaction, that is also an attract. Lucite rod and top tape interaction, that is a repel. So that's the opposite of your PVC rod. And then lucite rod and bottom tape interaction, you have an attraction. Which, if you look at your notes, is also the opposite of the type of interaction you had with the PVC rod. So then it says state top and top interaction based on charge. We haven't really talked about that word yet, but we could make assumptions about the type of interaction. So again, you can say that it repels, so they must have a similar charge. All right, state top and bottom interaction based on charge. So they're attracting each other. And like that phrase, opposites attract, so they're going to have opposite charges.
You guys can totally tell who's writing right now, by the way.
State bottom and bottom tape interaction based on charge. Right, so it should be very similar to the top part where they're repelling each other, and they have a similar charge as well because they're both bottom tapes. Mr. Hernandez is writing because I have a hard time writing and talking at the same time.
All good. Working together here. All right, so now that brings us to the back page. Imagine you can see the differences between the top and bottom tapes at the atomic level. On the partially separated top and bottom tapes, invent a way of representing how the tapes change as they are separated. Okay, so we know that they're going to have a separate charge based on our answers right here. Top and bottom. So opposite charges. So what we're going to do now is we're going to assign a charge, just like we learned our charges of our atomic particles back in chemistry. We're going to say our top tape, we're going to put some positives right here. And we're going to go into the different charged particles in our next video. So stay tuned for that one. And the opposite of positive, we're going to have on our bottom tape, we'll have some negative charges right there.